So looping. The advantages of looping. We've already kind of talked about this stuff a little bit. Using a loop control variable. Nested loops. Avoiding common loop mistakes. A for loop. Our language doesn't support a post-test loop, so I'll mention it and then we'll kind of just cruise on past it. And in characteristics shared by all structured loops. Common loop applications and similarities and differences between selections and loops. Whenever you see the word selection, think if. And then loop is a while. Alright, so why loop? Looping makes programming efficient and worthwhile. I like that, worthwhile. But everything you use on the internet, on your computer, is built with loops. Your program is sitting there waiting for you to type stuff into it. It's looping. Your browser's sitting there waiting for you to type in an address and to hit enter. That's a loop. And then when you actually load a web page, it's got to display the web page on the screen. And so it's got, these 100 lines of HTML. It's going to loop through them, displaying them on the screen. You're playing a game. It's sitting there looping, waiting for your input, and then every time it gets some input from you or from the internal counters or from the other people playing the game, it updates it. So loop, loop, loop. Loops are why computers were actually created. Write one set of instructions to operate on multiple separate sets of data. When we were drawing our squares and our triangles and things like that, we were just copying and pasting code. Right? Turn left, go forward, turn left, go forward, turn left, go forward. So, we had 4 copies of each one of those statements. But with a loop, we could have written it so that it would all run. Let's do that. Let's make our itty-bitty little turtle program that draws shapes using a loop rather than with copying and pasting. So I'm going to do File New. Save my program outside of the Python 3632 directory. July 7. July 9. Yeah, thanks. Okay. All right, so when we do our turtle programs, there's a couple of setup steps we always have to do. The first one is to import the turtle library. The second one is to create the turtle itself. Call it T, call it Leo. T, Leo. We're going to use good old Leo. Leo is equal to turtle, all lowercase, dot, capital T turtle, parentheses in parentheses, and if you leave those parentheses off, it's not going to work. And then if we were going to go whole hog like that one page that we were looking at, we could create a window and set a background color too. And then use the main loop statement. So, that reminds me, if you need to do some Python programming, but you don't have it installed on your computer, there are websites which have Python interpreters on them. One that I've used a lot, if you do Python space 3 space REPL, like reply, REPL.IT, REPL it. If you Google that up, you get the little Python interpreter. So you can log in with a Raider account or something like that. So print hello. All right. So I'm going to run my program and it prints hello. So you can write your programs online. Copy them to a Word document and or a text file or something, in order to submit them. But that's if you don't have Python installed on your machine. You can even access it from your phone, so during lunch you could be writing Python programs, because that's what we all like to do. So we have our turtle. Let's do this the right way. Where is our web? How to think like a computer scientist link. Online reference. How to think like a computer scientist. I'm going to go to the chapter called Hello Little Turtles. Here we go. He calls his Alex. But import turtle, and then WN is equal to turtle.screen. I'll do that one as well, just so that we can call main loop. And we could change the background color if we wanted to. So WN is equal to turtle.screen with a capital S, and make sure you put the parentheses. Okay, now we're going to draw a pentagon the old way, without looping. So, the angle for a pentagon, I don't know what it is, but I know how to calculate it. 360 divided by the number of sides in the shape gives you the angle. So angle is equal to 360 divided by 5. And let's go ahead and give ourselves an edge length. I want each edge to be 50 pixels long. So now I'm going to write two statements, and then I'm going to copy and paste them 5 times to draw the whole pentagon. We're going to do Leo.forward and go forward edge. So Leo.forward, parentheses, edge, end parentheses. And then Leo.right and turn the angle. We could have also done Leo.left. Now those statements, since I'm drawing 5 lines, I need 5 copies of them. So that's my first copy. I just highlight them, paste. That's my second one, third one, fourth one, fifth one. Now I'm going to use that wn.main loop. And by the way, that turtle, that Python interpreter at REPL.it doesn't support turtles as far as I know. We could give it a shot. Let's find out. Let's take this program and paste it into that little editor that I showed y'all. I have no real confidence this is going to work. Yeah, it doesn't know what that is. So maybe REPL.it Python 3 turtle. Maybe there's one with it. Python with turtle. Cool deal. So we could be teaching this class.
I actually kind of like that a little bit better. It looks cleaner.
Yeah, I kind of like that. Having the 2 windows side by side. I'm digging it. All right, I'm going to post a num queasy notification. I do not know why it says that, but I'm going to post a link to this. Can we stop with this silly harmonious overjoin? Okay. Anyways, let's go and paste this link. Not sure why we wouldn't just use this one the whole time. Guess I'll keep doing idle. I almost liked that interface better. Let's, so here it is. We copied and pasted that stuff. That's nasty looking. Here's what we're going to do instead. Just comment all that stuff out. Now I still have that main loop statement down there somewhere underneath. So make sure that we put everything above. If you stick main loop and then you write some code underneath it, it'll never get to it. Right, so if I do leo.circ, don't do this, I'm just going to delete it, but this is just a demonstration. When you run a program and you go, it didn't draw my circle, the reason why is because that main loop command, which just sits there and holds the window open, needs to be the last thing in the program. Alright, so here's what we're going to do. We're going to write a loop. For x, now let's do the simplest loop possible. Simples. X is equal to 0, just our counter. While x is less than 5, because we want to draw 5 sides. Now paste those 2 lines of code that we had, or just type them in again. Leo dot forward parentheses edge in parentheses. Leo dot right angle, and then x equals x plus 1, or just x plus equals 1. I think I am going to delete all these comments. They're cluttering up the screen. And there we go. It ought to be ready to go. So, that shortened the code, right? You know, if we made this 5 a variable, a constant or something, then we could make it to where it would draw a shape of however many sides we wanted. So why don't we change that 5 to the word corners, like that. Spell corners. There we go. C-O-R-N-E-R-S. Copy that and replace the other 5 with it too. Now that'll be a syntax error until we actually have a set, a declaration. So corners is equal to 5. So what are we doing? We're creating our turtle, we're creating the screen for him to draw on, and then we have a set, you know, a declaration, we have a calculation, we have another declaration, whatever. We set our counter equal to 0, and then as long as that counter is less than the number of corners we want to draw, we draw a line, we turn, and then we add 1 to that counter. So this is what's known as our loop control variable. It's controlling the loop. This is a simple loop. It's just going to count from 0 to 1 less than the number of corners. Right? So if we have 5 corners, it's going to count from 0 to 4. Why? Because 0-based indexing. 0, 1, 2, 3, 4. It's still 5. It's just starting at 0 rather than 1. Alrighty. But if I change that 5 to something else, it should still work. I really don't want to play with that REPL turtles. Yeah, that's pretty neat. This text is small though. I'm not sure if that's hard to read. I have to kind of zoom in. My mind is mulling over the possibilities of doing it like that. Alright, so everybody got it to do that, right? Not yet. The next thing we're going to get it to do is to draw kind of a spirograph looking shape or something like that, where it draws a circle and then it rotates a little bit, and it draws another circle and it rotates a little bit, and so on. So let's do the same thing. x is equal to 0, we're going to loop the certain number of times, but instead of drawing a line, we're going to draw a circle. So while x is less than corners, well, I guess it's not corners anymore. Yeah, stick with it. Leo dot, nope, we're not going to go forward. We're going to draw a circle. Leo dot circle 50, and then Leo dot right angle. And then x plus equals 1. I'll bring the code back.
What's the x plus equal to 1 for exactly?
We have to increase x, or else the counter, it'll be an infinite loop because x would never grow to be larger than the number of corners. So we're doing x plus equals 1, which means x equals x plus 1. We got to do that or else our loop never ends. It would just keep drawing circles or drawing lines until we close the program. There is a shorter form of this loop where you don't have to type in the x plus equals 1. Let's do that as well, and then this may be the end of the turtling, I'm not sure. The syntax, this is what's known as a for loop, and we will be talking a lot more about for loops. For x in range 0 up to the number of corners, increasing by 1 each time. So for x in range, parentheses, 0, comma, corners, comma, 1, end parentheses, colon. Anytime you use the tab key, there better be a colon on the line before. That's why we have a colon here after these while statements, just like we would on an if. Same is true for a for. Now let's draw another little circle. Leo dot circle 20. And then Leo dot right by our angle.
How do I change the speed again exactly?
If we want to try to speed it up, after we create Leo, let's do Leo dot speed parentheses 0 for max speed. 1 is slowest, and then as the numbers get larger, it speeds up a little bit. So 1 was pretty slow. Let's give 10 a shot. Circles just seem to take a long time to draw. The straight lines went really fast. Okay. So since we made this all based on variables, we could change the number of corners. Wanted to draw a triangle, change the corners to 3 and run it. Draw a whole bunch of somethings. I don't know. Corners is equal to 10. A decagon or whatever that is. And that's going to take too long. So I'm going to stop it. But yeah, it's almost done. All right. So what would be cooler would be as if we turn these into modules so that we could draw a polygon anytime we wanted to with just one line of code rather than with 5 lines of code. But be that as it may, the difference between the for loop and the while loop is that in the for loop we got to specify the beginning position right there. We didn't have to say x is equal to 0 above it. We just put a 0 there. And then we put our testing condition right there, corners, while x is less than corners. And then this is what's known as our update. And we put our update right there. So generally in a loop there's 3 steps. 4 if you count the loop actually doing anything. But step 1 is to declare your counter. Step 2 is to have your testing condition. And step 3 is to update your counting variable, because if you don't update it, it'll be an infinite loop most likely. And the for statement lets you specify all 3 of those things in one line of code. So it's kind of useful. And we'll see another use of the for syntax to step through a list in just a moment. Well, maybe not just a moment, but we will. So a loop is a structure that repeats actions while some condition continues. As long as x is less than the number of corners that we wanted to draw, keep going. Simplest loop. Just something that prints numbers. I don't even know if we need to type this in. I guess we could do it above our import turtle. X is equal to 0. While x is less than 10, print x. That's like the super easiest, simplest loop. Except I've made a mistake. What is that going to do? Yeah, that's exciting. What did I do wrong? All it did is print a bunch of zeros. Not what I was hoping for. Same thing I was asked about earlier. What do we have to do in our loop in order to prevent infinite loops?
You put an if while statement.
We need to change the value of the variable that we're checking.
Gotcha.
So we've got to do like an x plus equals 1 or something. Now it'll work. Yeah, so we got our numbers there, 0 through 9. Yeah, so you initialize. I'm going to call it LPV for loop control. No, L loop control variable, LCV. I don't think they do that. I may never do it again. And then you have your condition. And then you have your update of your loop control variable. So if we're using a while loop to have a program keep running until the user types in something like, do you wish to play again? Yes, no. That play again variable is the loop control variable. So if you use looping, less time required for design and coding. Fewer errors, shorter compile time. If I was going to draw a shape that had 100 circles in it, and I copied and pasted that circle command 100 times, that takes longer for it to compile than if I just had a loop. While or for x in range 0, 100. So a dual alternative or binary selection structure provides an action for each of 2 possible outcomes. I don't know why I would call that dual alternative. But this is a while. This is a while loop. While, condition, do something, and then repeat. And as long as something can change that condition, eventually this will no longer be true and it will fall through. So do some declarations, do some housekeeping. Are we at the end of the file? Not EOF? Yes, we are not at the EOF. Okay, do our detail loop. Our detail loop does something with the data. And then come back in and get another line of data. Are we still not at the end of file? Yeah. Do our detail loop again, whatever it is. Come back through here. All right, we have hit the end of the file. So is not EOF true? No, it is not true. We do our end of job stuff and then stop. The mainline logic common to many business programs. So a loop control variable, as long as the condition remains true, the statements in the body of the loop execute. This is the body of that loop right there. This is the body of that loop. Everything that's indented inside that while is the body of its loop. So that can control the number of repetitions. You initialize the loop control variable before you go into the loop. You test it, and then you alter it. Okay, so great, they're using slightly different terms than what I use. I'm going to go back in and update my comments. You initialize, you test, and you alter. All right, instead of condition and update, but they mean the same thing, right? So loop control variable used in the while loop to control the number of repetitions. Control the repetitions. So every loop with a loop control variable, you'll have an initialize loop control variable, you'll have a test loop control variable step, which is your while, and then you'll have some body of code, and then underneath there, after that body of code, you'll have an update. That's what they call it, alter loop control variable. So the syntax is like this: x is equal to 0, and then your condition, while x is less than 10, colon. You do your body of your code, whatever it is, and then you alter it, x plus equals 1. Now, it doesn't have to be 1 every time. You could be asking for input, you could be checking a sensor for input, you could be generating a random number, you could be adding 10 to it, you could be subtracting, whatever. But as long as something will alter it so that this is no longer true. And if we were going to, if this was pseudocode rather than Python, we'd tack on the word end while. Going to leave that out, I guess. Because if this was going to be pseudocode, I'd have to put the word set there and whatever. Okay. Well, if that is our loop control, if that's our pseudocode, let's actually write some Python. X is equal to 0, while x is less than 10. This is just the same code that I wrote in the program itself. Print x, and then x plus equals 1. So that's our pseudocode. That's our Python. So the repetitions are controlled by the counter. We can use a counter to control a definite counter-controlled loop, or we can have a sentinel value for an indefinite loop. What's the difference? Well, we were using definite loops, counter-controlled loops, because we wanted to draw exactly 5 circles or 10 circles or whatever. But use a sentinel value if you don't know when you're going to stop. Add up all these numbers until there's no more data. We don't know, quote, how many numbers there are going to be. Or, enter test score or -1 to quit. We're not sure how many test scores, so we're going to let the user tell us when to stop. That's called an indefinite loop, and that uses a sentinel value. So you can have definite loops, counter-controlled, or you can have indefinite loops. Sentinel value. All right. Why don't we pause, get back together at 120. So just like the last slide, because we're going to be thorough, a definite loop, a predetermined number of times. That's what that for statement is good for. Definite loop. If we want to count all the numbers between 1 and 1,000, we can do so. We know the starting point, we know the end point. A counter-controlled loop, or a counted loop, the program counts loop repetitions. So the loop control variables, you can alter them by incrementing. You can alter them by decrementing. We want to count down. You know, when's the rocket going to launch? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. You would use decrementing. X minus equals 1 rather than X plus equals 1. And a counter. That's the numeric variable that counts the number of times an event has occurred, usually starting with 0. Although, you know, if you were going to count down from 10 to blast off, you wouldn't start it at 0. So an indefinite loop performs a different number of times each time the program executes. We don't know how many test scores we're going to add up. We don't know how many, you know, excuse me, you know, how long the player is going to play until they run out of Pac-Man lives, something like that. The user winds up deciding, oh, for Pete's sake, the user decides how many times the loop will execute. Output, do you wish to continue? Yes, no. Not sure why I would say that before the program even ran, but input should continue. As long as should continue is equal to Y, we output hello, and then we output again, do you wish to continue? Input should continue. And so that's our loop control variable being altered, being updated right there so that it's not an infinite loop. Here's where we declare, well, they declare the we initialize our loop control variable there, and then we test it in the diamond. And then whenever they type in anything else other than Y, should continue is no longer equal to Y, and so it falls through. Have we done the guessing game yet, where the computer says, I'm thinking of a number between 1 and 100. Have we done that yet? Okay. That's about the best example of loops I can come up with, besides, you know, just the simple ones like adding up all the numbers between 1 and 100 or whatever. So what we're going to do is we're going to write a little program that works like this. I'm thinking of a number between 1 and 100. Take a guess. So we guess 50. It says wrong. Guess again. We guess 30. Correct. You got it. Do you wish to play again? They type in no, and it says, okay, goodbye. That's how I want it to work. Except, obviously, it's going to keep looping until they get the number right. So this is going to be one loop right here. The guessing portion of it is a loop. And then when we ask them if they wish to repeat, that's another loop. That's what's known as a nested loop. It's going to look something like this. They were calling it should continue as their repeat variable. I think I'm just going to call mine again for shortness. Okay, so this is going to be pseudocode. Set again equal to Y. And then while again is equal to Y, we're going to run our game, play our game. And then at the bottom, we're going to say print, do you wish to play again? y/n, and then we're going to ask for that. I guess if this is pseudocode, that should be output, whatever. And we're going to input again. So this is going to be another loop right there. Play the game is going to be a loop. So it's a loop inside the loop. And then once we're done with that loop, we'll just output, okay, goodbye. Now let's create a new idle program, rather than just keep tacking stuff onto our turtle program. And we're just going to code this part of it right here. And then we're going to go back in and we're going to fill in the good stuff, which is the actual playing of the game, the picking the random number and all that stuff. Okay, so I did a file new. I'm going to save it as July 9 space guessing game.py. Put my name up here. Date, what it is, number guessing game. Alright, if I knock this over here, I can get it on the screen along with my pseudocode. Alrighty. So, again is equal to y. I could pick a better variable name, but I don't want to pick something that's too long to type. Like repeat. Repeat's a good word. I'll just stick with it again. Yeah, I like the word repeat. We're going to change that. While repeat is equal to y. And then while repeat equals quote y. Now here's what we're going to fill in. So I'm just going to print a message. Game ... just for now. And then we're going to print, do you wish to play again? y/n. And then repeat is equal to the input. Now I'm just going to put a little comment here, end while. Not necessary. And then we're going to print out, okay, goodbye. Alright, so it played the game, and now it's asking us, do we wish to play again? You're like, yes, no. So I'm going to type in yes. That was fun. Alright. Game. Do you wish to play again? Why not? Alright, I'm getting bored of the game. I'm going to type no. Okay, so the program worked as designed so far. Just a second, I'm going to save these notes so I don't accidentally lose them. I really want to make sure that nobody is stuck at this point because we're going to be going a lot further. Alright, so the game is a part that we need to fill in. We could make it its own module. It'd kind of clean the code up and demonstrate some abstraction. Maybe we ought to do that. So up above the repeat equals y statement, I'm going to define a module called game. DEF game, parentheses in parentheses, colon. And for now, I'm just going to put return. And where it says print game, I'm going to replace that with a call to the module. When we flowcharted it, this would be a box with the vertical bars, or horizontal bar if you were using Microsoft Office Visio. All right. Now this time when we run it, it's going to do even less. It's not going to even print a message, right? It just keeps asking us if we want to play again. But that's okay. We're providing the skeleton. Now inside this game module is where we're actually going to write our code. What are the steps we need? We need to pick a random number. The computer needs to pick a random number, right? 47, 35, 99, whatever. And then we need to let the user input a guess. We need to check that guess to see if it's right or not. And we're going to keep looping until they get it right. So we need some kind of loop control variable. Maybe something called correct, and we're going to keep repeating until correct is set to yes or y, something like that. And we're going to need a random number. So let's do some declarations up here. I may not get them all, but I'm going to give a shot at it. The random number I'm going to call target. I'm just going to totally pick at some point, a better random number. But for now, I'm just going with 34, right? Just for testing purposes, rather than write the code that'll actually pick one. All right, we're going to need a variable called guess. That's what the user's going to type in. We don't know what it's called yet, so I'm just going to pick it as 0. Set it to 0. What else do we need? We need a variable that controls the loop. Correct. Correct is equal to no, because it's not correct yet. They haven't gotten a guess. And so our general, let's do this. While correct equals capital N colon, and that's where the bulk of our game is going to be. But before we start telling them, before we go in the loop, we need to tell them the rules of the game. We need a couple of print statements above that while. Let's play a guessing game. I'm thinking of a number between 1 and 100. Something like that. So above that while, print, let's play a game. And then on the next line, print, I'm thinking of a number between 1 and 100. Inside the while loop, and again, we're not going to carry it the whole way through before we run it and make sure that we don't have any syntax errors. So this is going to be the last thing I type before I run it and test for syntax errors. So print, what is your guess? Question mark. End quote, in parentheses. So when I run it, it's just going to print that message a million times because nothing ever updates, alters the value of n. Yeah, that's what I was expecting, but at least there's no syntax errors. That's called an infinite loop. I want to see everybody's screen do the infinite loop. A lot of programmers like programming on a dark screen rather than blinding white. You can change that. Options, configure idle. And then there's under highlights.
Yep.
Go to highlights, choose a built-in theme. You can choose idle classic, idle dark. What's idle new look like?
Oh, no, it's just white.
Yeah, no difference between them. Okay. And I should have an OK button down here at the bottom, although I can't see it. Come on. There. I'm going to switch back under the hope that it's easier to read on white. But on your own screen, you might like it black. I don't think that's true black. I think that's a very dark navy blue. I could be wrong
It
on
looks
that.
purple from my angle.
Yeah. All right. Okay, so inside here, we need to actually ask for their guess. We need to compare it. And if they've got it right, we need to tell them and set this loop control variable equal to y, so that it'll stop looping once they get it right. And if they've gotten it wrong, we need to tell them that. So underneath our print message, let's do an input. Guess is equal to input. And as always, we need to convert it to a number. We could convert it into a float, but in this case we really hope that they're typing in whole numbers, because if I played a game, I'm thinking of a number between 1 and 100, and then my secret number was 35.439. Once you figure that out, you'd beat me up. So why don't we convert it to an int? Float would work just as well. We've used float everywhere else. Why not make it float? Okay. Guess is equal to float guess. That way, at least it won't crash if they type in a number with a decimal point. But really, my instinct is to make this int there. So either way you want to do it. Okay, we've got their guess. Now we need to compare it to the target. If guess is equal target, colon, there's that use of double equals. Let's let them know. And then let's set our loop control variable equal to, you know what it's called if you have a variable and the loop is running until it hits a certain value? Kind of a sentinel value, but in this case it's known as a flag. We're going to flag when it's correct. And a flag should really be a Boolean variable that we set equal to true or false. So I should have said correct is equal to true, but I'm just running with the simple stuff here. So here we go. If it's correct, we're going to print them. We're going to print, quote, you got it. And we need to reset that variable to a value that'll get it out of the loop. So correct is equal to, quote, y. Otherwise, we need to tell them they got it wrong. Else, colon, print. Nope, try again. And I am going to put a # indiff just to make it look like pseudocode. Not necessary. And I'm going to put a # int while indented one level back. And then my return underneath that. All right, the module is now more than one page, one screen full worth of data. I think I'm going to delete the word declarations so that that fits on the page. It'll be the last point at which it all fits on one screen now. And that's just on my screen. Y'all have lots of space on yours. I'm going to run it, see if it's working. Now I've already forgotten what I set my guess equal to. 50, nope, try again. 25, nope, try again. What did I set it to? I'm going to come peek. Oh yeah, 34. 99, 34. All right, you got it. Do you wish to play again? And if I say Y, if I say yes, I want to play it again, it goes back into the game. Hopefully it picks a different number. But it doesn't, right? Because computers do exactly what we tell them to, and it didn't pick a new number. Now I'm finally tired of this game because I figured out that it's the same number every time, so I choose no. It says, okay, goodbye. Okay, I would like for it to work that good, but I can think of an improvement. What would make the game more fun? At this point, we're not giving them any information about why it's wrong, right? If we were playing the game and I wanted you to guess a number between 1 and 100 and you told me a guess and I just said wrong, and so you had to guess again and you had to guess again, that'd be tedious. What information would you want to know about your guess?
Higher or lower?
Higher or lower, right. So we're going to wind up fixing this else statement to allow ourselves to find out if it's higher or lower. We could use elif, or we could use a nested if. I may just make it a nested if, but for now I want to walk about and make sure everybody's got where we're going.
Can you just go to the bottom of the script?
Sure. Okay. I did not mean to launch Visual Studio. Get lost. Okay. Okay, so if I want to put some code in to tell them if it was too high or too low, about which section should I fix?
The note try again part?
Yeah. So I'm going to put another if branch inside this one. I could also do this with elif, but let's just use a nested if. If the guess is less than the target, I'm going to print a message. Print, nope, that was too low. And then backspace, else, colon, print, nope, that was too high. I'm going to change the word nope to sorry in one of them just to kind of give them some distinction. And # endif. And are all these endifs necessary? No, they're just to kind of visually break up the code the way pseudocode would, and it makes seeing the logic of it a little bit easier. I do that kind of thing even when I'm not demonstrating it for students, back when I was doing all of my professional coding. All right. I think we have just about a perfect game. I could think of maybe another feature or two we could add to it, but I think it's about I think the game is just about, oh wait, there's one very important thing we need to add to it. Because it's boring at this point. Why? Because it's always asking for the same number.
Whoops.
So testing it out if I can. I'm thinking a number. What is your guess? My guess is 50. Sorry, that was too high. Okay, I'm going to guess 25. That's too low. I'm going to try to pick a number between 50 and 25, like 37. Nope, that was too high. Then I get just ticked off and I start counting down by ones, 36, 35, 34. I got it. Do you wish to play again, YN? Okay. So the most important thing for us to fix is to have it actually pick a random number. And fortunately, there's a Python command that'll give us a random number. What's a random number? It's just one that you can't predict. Like rolling a die in a game. All right, so the most important thing to fix is so that it doesn't always choose 34. So I'm going to Google up Python random in order to get the syntax for doing that. Yeah, I probably remember it, but so Python random. Generate pseudo-random numbers. And whenever you're Googling up help, don't go to the Python 2. Quite often the syntax is the same, but sometimes it'll be very different. So Python 3.7. the random number generator. I'm just going to kind of scroll down. You can generate a random number between a range. That sounds good. Maybe we'll use that. We saw that range statement in that for loop. So I feel like doing that. Okay, so to get the random library, I have to add an import, just like we did with turtles. So above my def game, import random. And my target, I'm going to replace that 34 with rand range. And the way the rand range works is you specify a starting point, 1. We specify a stopping point. Is it going to be 100 or is it going to be 101? I'm going to have to do a little bit more reading. And then, what do I want my step to be? The step would mean, like if I want a number between 10 and 100, but I want it to be divisible by one, an even number, evenly divisible by 10, I would put 10 there. But I want all the numbers between 1 and 100. So I'm just going to put 1. Now the question I have in my mind is whether this 100 is inclusive or not, whether this is going to generate a number between 1 and 100 or a number between 1 and 99. I'm suspecting that it's going to be 99. I'm going to read the documentation a little bit more clearly because that's the way the range statement works in a for loop. Rand range is not defined. Okay, what have I done wrong? Oh, I need to include, you know how when we were doing turtle.turtle and turtle.screen, I needed to prefix this function call with the name of the library. Or I could do this. From random import renge. What this says is that from that library, bring in this one function. If I didn't do it that way, I would have to type this, random.randRange. But I'm going to delete that because I have this nice syntax there. All right, I'm going to test it, and then I'll bring the code back on the screen. I'm going to try to get the actual guess. If we wanted to cheat, we could have it print out a hint, right? Like, psst, the number is, 100, just for test purposes. But I'm going to actually play the game. What's your guess? 50. Nope, too high. 25. Well, I typed 24. Too high. 12. Too high. Go, what the what? Alrighty. 6. Too high. Alrighty, I'm beginning to suspect that there's a problem. 3. I got it. Okay. I'm going to see if it's 3 again. No, it seems to be working. It's actually generating random numbers. So I'm going to bring this code back in case y'all need more time. Here's the lines that I added. Don't put these little markers there. But I added those 2 lines and I changed that line. That's just for your reading purpose. All right, so I'm going to take another peek at the documentation to figure out whether rand range needs to actually be 100 or 101. And as soon as we're done with this, I'll explain a little bit more why I'm suspecting that. All right, so random range, start and stop, which is the same as start, stop, step. Okay, then I'm absolutely sure it needs to be 101. Why? Because it would never pick the number 100. And we'll prove that to ourselves with a for loop in just a minute. Okay, so that's my last change.
Wouldn't you need to make that 1 before the 101 into 0 if that was the case, though?
You would think. The way it works, yeah, the question is, would I need to make it 0 to, for the same reason? And the reason why is because this is the start and it's inclusive. meaning that it will generate a 1.
Okay.
But 101 is exclusive. It never gets up to 101. And that's kind of weird, but once we play with the for loop a little bit more, hopefully it'll make a little bit more sense.
Gotcha.
Anybody need any more typing time, or is the game working for you? Everybody good? Alrighty. Okay, so that game is done. But I want to demonstrate for loops. We've already seen a while loop. Something like this. X is equal to 1 while x is less than 100 colon print x, and you don't have to type this. You don't have to mess up your beautiful game unless you want to. X plus equals 1 end while. Now what is that going to print? It's going to print 1 to 100 or 1 to 99. And the key is whether it's stopping at less than or equal to. If it was less than or equal to, it would count up to 100. But if it's just less than, it's only going to count up to 99. Why? Because once it gets to 100, is 100 less than 100?
No, it's equal.
Right, so it would fall through the loop. So it's only going to print 1 to 99 there. Let's prove it. Okay. So if I use less than rather than less than or equal, then it's not inclusive, meaning that it'll never reach that number, or once it exceeds that number. The inner loop will have stopped at 99. The for statement works the same way. For x in range, starting at 1, going up but not including 100, increasing by 1 each time, print out x. So again, that's going to print out 1 to 99. If I want to make it print out 1 to 100, sure, I could fix that like that. But there's no change equivalent that I can put down in this range. The range always works like just a less than rather than a less than or equal to. So if I wanted to go from 1 to 100, I'd actually do that, and I'd actually do that. Why am I spending time talking about that? Because this logic is pretty easy. You understand less thans, but the range is counterintuitive. You expect this upper value to be included in the range, but it's not. That would go from 1 to 100. And so would this. And I guess I'll add my little comment, unless we used less than equal. Like that. In which case, it would go to 101. Let's go ahead and add the counter for the wrong number of guesses. We're going to need one more variable. So in our declarations, let's declare one more variable called numGuess, or turn. Yeah. Turn is equal to 1. Where are we going to print our turn? On the error message, at the end of it. Let's do it at the beginning, where it says, what is your guess? So print turn number, end quote, comma, and then the word turn. And then if they get it wrong, we're going to increase turn by 1. So down here, else turn plus equals 1, which means turn equals turn plus 1. And we could put some logic in there to make it stop if the turn exceeded 10 or whatever our maximum number of turns is going to be. All right, turn number 1, 50. It blew up. All right. I typed in something other than a number by accident. What's your guess? 50? Too high. 25? It better not be 3 again. No. Okay. I'm not following that binary algorithm that I mentioned perfectly. And that's probably going to... Okay. Especially if I'm typing 2s when I meant to type 1. Okay, so it took me 10 tries. It should not have taken me 10, but I didn't follow that algorithm perfectly. I think I remember the formula for calculating it. I'm going to see if I can type it into Google. The log 2 of 100 is equal to 6. So at most, it should take 7 guesses if we played it perfectly. This just happens to be the formula for the binary algorithm, the maximum number of searches, number of guesses it would take. What if it was 1,000? Then they ought to be able to guess it within 10. That seems counterintuitive, right? But what's the first number you're going to guess if it's between 1 and 1,000? You're going to guess 500, and then you're going to guess 250, and then you're going to guess 120. Anyways, it winds up just being 3 more guesses. What if it was 1,000,000? 1, 2, 3 zeros, 4, 5, 6. Within 20 guesses, you can find it. That's pretty neat. Now, I don't actually want to play that game, but all right. So the lines I added in order to get this to work. I'm not going to actually program in the limit, but if I wanted to, I would just change my while statement. While correct is equal, yeah, why not? But then I'd have to put some more if logic down at the bottom to explain why they lost. Something like that. So I'm not going to. But if I wanted to put that in there, I would change this. While logic, and don't do this because I'm going to immediately delete it, is equal to n and turn is less than or equal to 10. Right? We're going to allow them 10 turns. That would be a good limit. It wouldn't take that much more to tell them why they lost it. But then we ought to tell them that they have a maximum number of guesses and all that to be correct. So I'm going to take that out. I ought to make it an extra credit assignment. I'll do that. Just to remind myself. Extra credit. Modify the program to properly support a max number of turns. What would you have to do? You'd have to tell them before they started guessing, and then at the end of the game, if the turn number was greater than the max, then tell them, then output too many guesses, sorry. Something to that effect. So it'd really only take 2 changes. Earn some extra credit. Extra credit is good, especially if you didn't make an A on the exam. You might want to bump it up. And heck, if you did make A on it. Okay. All right, we're almost gotten as far as I wanted to get, because the next task we want to do is to flowchart this, and this is a bear of a flowchart. It's a lot of code. So let's go back to the PowerPoint. Using an indefinite loop with a sentinel value. We could have put a sentinel value into our code. We could have told them that if they guess 0, it's going to quit immediately. That would be a sentinel value, right? Take a guess, 1 to 100 or -1 to quit. That -1 to quit is a sentinel value. A sentinel value is an invalid piece of data that signals the program to stop looping. So understanding the logic you have to provide a starting value, the initialization. You have to test the loop control variable. And we did that in both cases, right? What is our loop control variable in this game module? It's the variable that our while loop is based on.
Would be correct.
That's correct. Yeah, that's right. That is the loop control variable, and we provided an initial value. Why did we provide an initial value? Because if that was commented out, then when we run it, it's just going to blow up. Why? Local variable correct is referenced before assignment. If you don't set a value into it, we can't compare it. So we had to initialize it. Then we have to test it. Without the test, it'd be an infinite loop. And then after the loop control, within the while loop, alter the loop control variable. Because if it never changes, it would also be an infinite loop. Now you can have a loop that never executes. What do I mean by that? What if we set correct equal to yes right there? How many times is it going to ask for guesses? Correct equals y. While correct is equal to no, it's just like an if statement. Would it execute the body of it in this case? If correct is set to yes, and then we had if correct is equal to no, or while correct is equal to no. Would it even go in here? I think I heard the answer.
It would not.
No, it's not going to even go in there. Why? Because this test condition is not true to begin with. So you do have to kind of be careful that your while loops have a chance to execute at all. If you give them an improper starting value, then it's not going to go in there. There could be times when you want that to happen. Like if your loop control variable is an end of file indicator. What if the file had no data? Well, then it's not supposed to go in the loop and add up the numbers in the file or something like that. That's too much. Read the book. So a nested loop is a loop within a loop. The outer loop contains the other loop. The inner loop is the loop that's contained. We didn't actually write this in an easy to spot nested loop. But if I had taken all of this code, don't make this change. If I had taken all of this code and put it right here inside, replace the game module with that, the game would still work. I have demodularized it at this point. And now we have a nested loop. The outer loop asks to see if we want to repeat, and the inner loop runs as long as we don't have the correct number. That's a nested loop. Why did I break it the way that I did? Because I didn't want to just write all of this stuff in the main code, because it's harder to read. If you can modularize your code, it's better. And that's what I did. I created a game module so that our main code from here to here is very simple and clean. So you do this when the values of 2 or more variables need to be repeating to produce every combination of value. We have 2 variables. We have that one that asks, I've already forgotten the name of it. Oh, fiddly sticks. Didn't mean to launch that. So we had 2 in our, and I did it again. My brain is, we may need to end early. We had 2 loop control variables. We had one called repeat. We had one called correct. So we had 2 loops. This is an inner loop in effect, even though it's tucked away inside of another module. If we had written it the way that I did when I cut and pasted it, then we definitely have 2 loop control variables. We would have one called correct and one called repeat, and we'd have an outer module that used one of those, and we'd have an inner module that used another one. Let's make this about, it's way too early to stop. I gotta keep slave driving y'all. Okay. That's not a bad example. we're going to do something like that. So up here at the top of our loop, we're really messing up our guessing game. Like the Bible is broken up into chapters and verses. So I'm going to call something chapter. We're going to start off at chapter 1, and we're going to start off at verse 1. And then our outer loop is, let's say that this book only has 9 chapters. So we're going to count while chapter is less than 10. And the inner loop is going to be how many verses are there per chapter. Let's just say that there's 3 verses per chapter. So while verse is less than 4. Why? Because I want to count 1 to 3. Before I go into that while loop, I'm going to print a message that says chapter. So print chapter in quote, comma, and then the actual variable called chapter. And then inside the while loop, I'm going to print the verse. Verse, comma, verse. 2 end while statements. Nope, I can't start ending them because I haven't updated them. Verse plus equals 1. And then after the end while, chapter plus equals 1. Now I've forgotten a step. Once we're outside of the verse loop, we need to reset the chapter. Excuse me, we need to reset the verse. Or else, it'll try to print out verses 4, 5, and 6, and 7, 8, and 9. So on top of that while loop, I'm going to also set verse equal to 1. I need my loop control variable reset before I go into the inner loop. And then I'm going to put an input statement just to pause the program at this point. Input, press enter to continue. Why? Because we're printing out a whole bunch of stuff after this, and I want to see it all. I want to see this portion of the code run before it starts printing out numbers, 0 through 99 and all that. And there we go. You see what it did? Chapter 1, verse 1, 2, 3. Chapter 2, verse 1, 2, 3. Chapter 3, verse 1, 2, 3. And so on. Notice that the inner loop runs from beginning to end before the chapter is ever increased. That's the way inner loops work. This inner loop has to terminate before it can test the outer loop condition again. I don't know if y'all were typing that, but for anybody who was, I want to make sure that you got it in. Okay. So flowcharting a nested loop. Here's our outer loop. And I always put the word while to distinguish it from an if. You don't have to. The book doesn't. While x is less than 3 or whatever. Then come in here. While y is less than 3 or whatever it is. Keep looping. Our chapters and verses. We're looping our verses. Once we're finally done, we add 1 to our chapter. And then we come back out all the way out here, and it goes into the loop. And as long as, while chapter is an acceptable value, it keeps repeating it. And you see why the inner loop counts all the verses before the outer loop clicks again. Because this is all inside it. The inner loop has to repeat until it's done, and then it can repeat the outer loop. So nested loop facts. They never overlap. An inner loop is always completely contained within the outer loop. An inner loop goes through all of the iterations each time. The outer loop goes through just one iteration. And so that means that the total number of iterations executed by the nested loop is the inner loop iterations times the outer loop multiplied by. So if we go out and look at our code, how many total chapter verses are we going to be printing out? Well, we're going from 1 to 10, so that's really 1 to 9. We have 9 different possible values there. And here we're going 1 to 4.
So that's 3.
Thank you. 1 to 3. And so we're going to print out 27 different chapter verse combinations.
You got 9 chapters, 3, yeah,
Yeah, the question is, would it be 9 chapters or would it be 10? That'd make it 10. I'm always using less than at this point because it looks like the range statement. If I wanted to, I could replace these with range statements. For chapter in range, starting at 1, going up to but not including 10, increasing by 1 each time. Then I wouldn't even have to do this. I think I'll undo all these changes, but I kind of, maybe I'll copy and paste it both ways. I can do the same thing here. For verse in range, starting at 1, going up to but not including 4, increasing by 1 each time. That would work just as well. Now I don't have to initialize it because this initializes it right here inside that statement. Now let's just make sure it actually works. Yeah, okay. All right, let's make a Dropbox. Call it a done day. Just to mark where we are.